Okay, so today I have the biggest computer up here. That's the memory I have. 259 gigabytes lying around. Main memory, mind you. The disk is rather small. I'm renting these servers hourly because it's such a mega fat server. I can't afford it all the time, so I rent it hourly. And the disk is small, it's funny. Like, it has more main memory than it has disk space. That's really odd. But it's fine, I can work with it. So this is also the biggest Java VM you have ever seen, I guess. I have ever seen. The biggest one I have ever seen. It's so amazing. Big computers are like a trip of their own. You know, like between calculators and Commodore 64s and desktop computers and gamer computers and then servers, there's such a range of devices. Servers are unbelievably huge. That's one of the key tricks or ideas or principles behind like what Google does. They just have really big machines. And these big machines enable you to do new things. Just things you wouldn't be able to do without a big machine. Because what I'm doing here is I'm transforming Wikipedia. I took the whole 70 gigabytes, whatever the goddamn number is. I took the huge body of text that Wikipedia is, the English part for now, and I do a complete transformation. The computer looks at every sentence, every word, every structure, every chapter, everything, and makes its own representation, looking for anything that repeats, any bigger patterns. And it makes this index file that is just about as big as the original file, within a factor of whatever. You know, it doesn't really matter if it's half as big or if it's 5 times bigger. First we compress, so we take out some fluff. We take out unnecessary symbols. It turns out if you count symbols instead of characters, it's a factor of 10, roughly. For a text like Wikipedia, so typical natural language, if you compress it in this special magic way, it turns out you get 1 symbol per each 10 characters on average. So first we compress, and then we make a very smart structure that allows us to find any symbol using its letters really quickly. I did all of this before today, and it failed at the very last moment. I got some of the horrible exceptions that programming has to offer. Some kind of buffer overflow. So, like 1 or 2 hours or 3 hours of work down the drain. But it totally doesn't matter. It just doesn't matter. I just observe this and I enjoy it. This is so big. In the end, I split Wikipedia in 5 parts because the whole thing is too complicated. It doesn't matter. This is boring technical stuff. Anyway, they are big numbers. 1 billion pairs processed. So the actual algorithm behind this is not open source. I actually stopped open sourcing for this particular project. This is a secret search algorithm. I call it the honest search engine, because it doesn't invent anything. It doesn't change what you say or interpret it differently or send you to websites that are favorable to the search engine host or whatever, or try to sell you something. Maybe I will sell something too, I don't know. But the point of the search engine is that it just looks at the characters. You can enter any word, any phrase, anything, and it will tell you exactly how often this combination of letters appears in Wikipedia, in the whole vast body of it. So it's the honest search engine, and it's supposed to be really fast, which I'm gonna prove really soon now. So as you can see here, you don't see anything, but I'm proud of this design that I made with really short code and so on. What's the source code here? The source code is really short. This is the whole website. So I'm impatient for this process to finish. but I was too lazy to optimize this. This is happening on one processor core, and this mega fat machine has 56 cores. It's the biggest thing ever. And up here you see it only uses a few cores. So I could have optimized this and then run it again, then it would run faster, but first I have to code the optimized version. So in the end it might slow me down. So I just went with the process again. It has like 3 or 4 phases. Now it's making the calculations. Then it's doing a lot of sorting in a very smart way. And finally it writes stuff to disk. And then we have our mega index, and we can save it, turn this expensive machine off. It's $2 an hour. I mean, you get a lot of, you get beefy hardware for $2 an hour, but my funds are limited. So I make the best use of this machine, and then get back to more standard sized computers. I can't complain, my normal servers are also pretty big. Alright, I'm really excited about this one, man. This is something. This is a new mode of using the internet, using a computer, using an encyclopedia. Imagine you type something and instantly you get all the results. And then we can make fun little scripts. Like we start building AI, because AI is related to search, right? Search is a basis for AI. So use this ultra fast search and make some cool little scripts that, you know, little detectives, virtual detectives that scan Wikipedia for us and give us answers. Little chatbot built on Wikipedia. The dream will become real. Thank you, everybody.